Imagine this. A group of U.S. engineering specialists, some from top automotive labs, some from clean energy research centers, fly into Africa expecting to debunk yet another too good to be true electric vehicle claim. They arrive with their laptops, diagnostic tools, and a mindset shaped by decades of engineering tradition. But within just 1 hour of testing Africa's newest EV prototype, their entire understanding of modern electric vehicles is flipped upside down. This is the story the world isn't ready for yet. The moment the American team stepped onto the test facility floor, they immediately noticed something unusual. The African-made EV wasn't plugged in. It had been running all morning. The onboard instruments showed full charge and zero drop in battery levels. One U.S. engineer whispered, "Is the battery data spoofed?" Another replied, "No, it's legitimate. This shouldn't be possible." They ran their first standard test, a baseline energy drain cycle. In a normal EV, the battery percentage should drop predictably. But here, nothing. The needle didn't move. Not even by 0.1%. Their confusion deepened. They moved to the second test, thermal stress. The expectation, rising temperature. Instead, the EV stayed at a remarkably stable operating temperature, as if it had its own thermal regulation system that didn't require visible cooling infrastructure. Then came the turning point. The team inspected the powertrain and froze. There was no traditional charging port. No external input for grid charging. No hybrid gasoline backup. And yet, the vehicle's onboard system showed a continuous energy loop providing constant power to the drivetrain. One of the U.S. experts finally broke the silence. "This is not a conventional EV. This is something we haven't engineered before." Still thinking it might be a lab trick, they decided to perform a long-range endurance test. The U.S. engineers drove the car across rough terrain, steep climbs, and long stretches of open highway, pushing it far past the range limits of any commercial EV on the market. 500 kilometers passed, then 800, then 1,000. Not only did the vehicle never stop, it never dropped below full power. One engineer shook his head and said, "I'm not supposed to say this, but this thing is operating on tech we simply don't have." But the real shock came when they examined the energy system more closely. Hidden deep within the vehicle was a compact module unlike any EV system they had ever seen. It wasn't a hydrogen cell. It wasn't a solar booster. And it wasn't a capacitor bank. Instead, it appeared to be a self-sustaining energy regeneration unit, a design that had been theorized by researchers but never successfully implemented in a functioning vehicle. The lead American engineer leaned in, eyes locked on the device, and muttered, "This is what the industry has been chasing for 20 years. With every test, the evidence was undeniable. Africa wasn't just catching up, it was leapfrogging the world's top EV makers. And the Americans, who came expecting to dismiss the technology, found themselves quietly rewiring their assumptions about who leads global innovation. When the test session ended, the U.S. delegation gathered around the African engineering team. There was no skepticism left, only fascination and a level of respect they had not anticipated. "Congratulations," one expert said. "You've achieved what even our major automakers haven't." And that was only the beginning. Because what the Americans didn't know yet was that this EV wasn't the final version. It was merely the prototype. The real breakthrough, the one that could shake Tesla, BYD, and the entire global auto market, is still under wraps. The room fell silent as the African lead engineer stepped forward with a small, sealed black case. The Americans exchanged glances. They had already seen enough to challenge their understanding of EV engineering. What else could possibly be inside? The engineer placed the case on the table and said calmly, "What you tested today is only version 1. What's inside this box is version 2. The Americans leaned in, visibly tense. The case clicked open. Inside was a device no bigger than a smartphone, wrapped in a metallic alloy unlike anything the visiting team had encountered. It emitted a faint, pulsing blue glow, almost like a heartbeat. One of the U.S. energy specialists instinctively stepped back. "What is that?" he asked. The African engineer smiled slightly. "Call it an adaptive energy matrix. The Americans frowned. They had never heard the term. The engineer continued. This module doesn't just regenerate energy. It balances, amplifies, and redirects it automatically. And it does so with nearly zero thermal loss. A senior American engineer widened his eyes. That's not possible. Energy systems don't self-correct like that without external input. Until now, the African engineer replied. He then connected the module to a small demonstration board, a simple electric motor sitting on a table. No battery, no cables, no power source in sight. Then he activated the module. Instantly, the motor came to life, spinning smoothly, endlessly, with no fuel, no battery drain, no sound of strain. The Americans leaned in, trying to find hidden wires or a concealed power supply. There was nothing. The U.S. lead scientist whispered, "This violates every energy model we use." But the African team wasn't done. They revealed that the adaptive matrix could scale. From powering a toy motor, to powering a full-size EV, to powering homes, to powering entire microgrids. One American took a deep breath. "So you're telling me this thing could power a city block?" "Easily," the engineer replied. "With the right configuration, possibly more." The implications hit the U.S. delegation instantly. This wasn't just an EV breakthrough. This was a global energy restructure. An invention that could dissolve oil dependency, collapse charging infrastructure monopolies, and rewrite national energy strategies. They exchanged looks, the kind of look that said, "If this gets out, everything changes." The American delegation stepped aside for a private huddle. Their voices were hushed, their faces serious. They were doing the mental math, not just technologically but politically. Finally, one of them walked back to the African team and took a steady breath. "We need a full technical briefing," he said. "And we want to propose something." The African engineers raised their eyebrows. The American continued. "We'd like to form a joint research alliance. Immediately. The U.S. government is going to want to see this." But the African lead engineer responded calmly. "We appreciate that. But understand something. For the first time, we are deciding the terms." The Americans froze because in that moment, they realized the truth. Africa wasn't asking for validation anymore. Africa was leading. Rubbing his forehead. "That was a mistake," he admitted. "A big one. And now we understand what we overlooked." He paused. "And what we stand to lose." The African team didn't respond immediately. The silence lingered, long enough to make the Americans visibly uncomfortable. Then, without warning, the lights in the testing hall dimmed. A hum filled the air. Above the center of the room, a holographic interface flickered to life, projecting a swirling 3D model of the adaptive energy matrix, magnified, dissected, and animated. The Americans stared in disbelief. "Who's controlling that?" one of them whispered. The African engineer raised a small device, a wearable control ring on his finger. "It's part of the system," he said. "A real-time visualizer of energy flow patterns." The hologram rotated, revealing something the Americans hadn't expected. Multiple configurations, multiple modes, multiple applications. From automotive powertrains, to aviation systems, to stationary grid storage, to military-grade field equipment. One of the Americans stepped closer, eyes wide. This isn't a prototype. This is an ecosystem." A slight smile appeared on the African engineer's face. Exactly. The Americans suddenly understood the scope. This wasn't a single breakthrough. It was an entire energy platform, years ahead of anything on the U.S. timeline. The lead American swallowed hard. "We need to ask you something direct," he said. "Is this already deployed?" The African engineer hesitated for the first time. Then he answered. "Only in limited pilot zones. But yes, it's already running." The Americans froze. Every assumption they had walked in with collapsed instantly. One of them managed to speak. "What zones? Where?" The African team exchanged glances, and for a moment, it seemed they wouldn't say. But then, the project director stepped forward. "You'll see soon," she said. We didn't invite you here to negotiate ownership. We invited you because something bigger is coming. The Americans looked confused. The director continued. There's another upgrade. One we haven't shown yet. Something that required absolute secrecy. She tapped her tablet. A steel door at the far end of the hall slid open. What emerged was partially covered under a reflective thermal shroud, tall, metallic, and unmistakably humming with power. The Americans took an involuntary step backward. What is that? One whispered. The African director looked at them calmly. The next phase, she said. The one that will make every nation reconsider its place in the global energy race. She approached the shrouded object, gripping the edge of the metallic cover. And you're about to witness it before the rest of the world. She pulled the shroud back. The metallic shroud fell away, pooling at the base of the device, and the Americans stood frozen. Before them was a vertical cylinder, sleek, seamless, and silently pulsing with a faint blue glow. Thin conductive channels spiraled around its surface like veins, each one carrying a soft, rhythmic ripple of light. It wasn't just a machine. It looked alive. The director stepped beside it, placing her hand gently on the casing. This, she said quietly, is the Sentinel Core. The lead American's voice cracked. What does it do? Her answer came without hesitation. It's the first fully autonomous, closed-loop microreactor designed for mobile and stationary applications. It powers itself indefinitely. The American engineers stared at one another. A microreactor? Self-sustaining? Compact enough to fit in a vehicle? This wasn't incremental progress. It was a complete rewrite of the energy playbook. One of the U.S. specialists scrambled to take notes. That size, that output, the energy density alone would require. But he stopped when he realized the numbers didn't add up. They couldn't add up. A different American stepped closer, almost whispering. This should be impossible. The African director nodded slightly. That's what we were told for the last 20 years. She tapped the side of the Sentinel Core, and instantly the surface patterns rearranged, the spiraling channels shifting like magnetic ink. A soft hum resonated through the hall. Then the lights across the entire facility flickered, once, twice, and then stabilized brighter than before. The Americans realized what they were seeing. The Sentinel Core had just taken over the building's power load. Effortlessly, silently, wirelessly, one of the Americans staggered forward. You're running the facility off-grid? Not off-grid, the director corrected softly. Beyond the grid. Silence fell again, but this time it was thick with awe. Another member of the African engineering team approached a control pedestal and activated a transparent display. Performance graphs appeared. Zero input draw. Continuous output. Dynamic load balancing. Stable thermal profile. Efficiency beyond 100% measured, something the Americans could not comprehend. The lead U.S. engineer pressed his palm against the glass barrier, staring at the data. This technology will rewrite global energy protocols, he whispered. Transportation, manufacturing, defense, aerospace, everything changes. The African director nodded slowly. That's why we brought you here. The Americans looked puzzled. She continued. We have reached a point where the world will demand answers and verification. But we cannot let this technology be weaponized, monopolized, or buried. Her eyes locked with the U.S. delegation. We need partners willing to break old systems, not protect them. The Americans exhaled, realizing the weight of what was being asked. One finally spoke. What exactly do you want from us? The director stepped aside, revealing a second chamber behind the Sentinel Core, dimly lit, sealed, heavily shielded. Inside, something faintly glowed. This, she said, is the real reason you're here. She placed her hand on the biometric lock. If the Sentinel Core surprised you, what's inside this chamber will change everything you believe about energy, physics, and the future of mobility. The lock clicked. The door shifted. A pale, otherworldly light spilled out. The Americans shielded their eyes, stepping forward in disbelief as the interior came into full view. Suspended at the center of the chamber was a crystalline sphere. No wires, no fuel lines, no mechanical framework. It hovered silently, rotating with impossible smoothness. Thin arcs of energy curled around it like auroras trapped in a gravitational loop. The Americans stared, stunned. The director spoke softly, almost reverently. "This is the quantum flux cell." Maxwell Chikumbutso began early theoretical work on devices like this years ago. "What you are looking at is the first fully stable prototype." One of the American experts gulped. "A quantum-stabilized energy well? But that would require—" She nodded.
"Yes.
"A breakthrough in vacuum energy extraction." Another American stepped back, shaking his head in awe. "This is beyond anything we've developed. Beyond anything we've even imagined." The director approached the cell, holding her hand inches from its glowing surface. "This device generates continuous power with no decay, no emissions, no thermal risk, and no environmental footprint. It does not store energy, it sources it." The Americans exchanged looks of total astonishment. Everything they understood about physics, about energy itself, was being rewritten in front of them. "This technology," the director continued, "will power Africa's next generation of vehicles, aircraft, cities, and eventually, entire nations. Clean, perpetual, accessible energy." She turned back to the delegation. "And now you understand why we needed you here. The world will not accept this quietly.
Some will panic.
Some will deny. Others will attempt to seize or suppress it." The lead U.S. engineer took a breath. "We came here expecting to evaluate a prototype EV," he admitted. "But this isn't just a breakthrough. This is a turning point for human civilization." The director smiled faintly. "Exactly." She gestured toward the glowing sphere one last time. "This is not an invention. It is an invitation to a future that no longer depends on scarcity." The Americans stood silently, absorbing the magnitude of what they had just witnessed. And for the first time in decades, perhaps ever, they understood. Africa wasn't catching up. Africa was leading. The screen fades to black.